Okay, so goal is to evaluate and simplify algebraic expressions, and a variable is a symbol or a letter that represents a number. A lot of times we use X. If we're talking about an algebraic expression, okay, this is just going to be, it's also sometimes called a variable expression. And this is an expression, which means there's not an equal sign. And it's going to contain variables. So an example might look like 3ab minus 4. Okay, it's an expression. There's no equal signs. A and B are variables in there. If you are asked to evaluate, this is going to mean to follow the order of operations. Does anyone remember that word to help remember the order of operations? It's kind of a funny sounding word.
Please excuse me, Mrs. Fox. Did I give you a hint?
Or that phrase. PEMDAS. Have you guys ever heard of PEMDAS? What it stands for? Please excuse my dear Aunt Sally. Have you guys heard that? Okay, cool. So the order of operations is PEMDAS. If you can remember that, then you can remember the order to go about. Okay. A term is going to be a number it could be a variable, or it could be a product, meaning multiplication of the two. Separated by either a plus sign or a subtraction sign. Okay, so if we look up here, this example of this expression, this is made up of two terms. The subtraction sign separates terms. So we have a term that is here, the 3ab, and we have a term that's right here, 4. Okay. So if we put another example here, 3x minus 7y plus 9. How many terms are in that example? If this one has 2, how many terms does this one have? 3. 3x is a term, 7y is a term, and 9 is a term. So that one is 3 terms. 1, 2, 3. A coefficient is going to be the numerical factor in a term. Okay, meaning the number out front or in front of a variable. Okay. So in this case, in this first term here, what's the number? What's the number in 3x? 3. So 3 would be your coefficient. In this one, technically you have negative 7 is your coefficient because it's minus 7y. You think of it as negative 7 is your coefficient. This one doesn't have a variable, so technically your coefficient's just the 9 that you see. Okay. If we write an example here, maybe you have 12a. 12 is the coefficient. Okay, it's whatever number's in front of the variable, that's what we call a coefficient. All right, so the order of operations, these are a set of rules that give the sequence of math operations to perform when evaluating an expression. Okay, so the first thing we do, this is just explaining PEMDAS. The first thing that we're going to do is we're going to solve any operation inside parentheses. Or brackets. Sometimes you'll see brackets used instead of parentheses, but they fall under the exact same thing. Step 2, so if that was the P in PEMDAS, what comes next? Do we remember what the E stands for? Exponents, very good. So we're going to solve any exponents. So that's the next one. There's the E. Now, the next two is the M and the D, and those two are actually together. Anyone knows what those ones are? Multiplication and division. Very good. So you're going to solve the multiplication and division. So there's the M, there's the D, and last but not least, what's the AS? Add and subtract. So there's the A, there's the S, and that's PEMDAS. So the first example here, they are giving us an algebraic expression, a minus 2b plus ab. And they want us to evaluate, okay, meaning we have to use the order of operations if a is 3 and b is negative 1. So the first thing that we're going to do is we have to substitute 3 in for a and negative 1 for b. So we're going to write this. Instead of this first a, we are going to write 3 minus 2 times b is going to be negative 1 plus a, we're going to write 3, b is negative 1. So we just filled in anywhere there was an a, we put a 3, anywhere there was a b is now a negative 1. Now since this is all numbers, we can use PEMDAS in order to simplify it. Okay, we'll get it down to just one number. We'll do all the operations and get it down to a final answer, okay? Anyone notice how I put all the A's and all the B's inside parentheses? Okay, it is important to do that because a lot of times people miss a negative sign here or there if they fail to put those parentheses, okay? Also, sometimes it will affect your final answer, so you need to make sure that those, when you substitute those values in, they are put into those parentheses. So we have to handle, since there's nothing inside the parentheses that you can simplify, there's no operations inside that parentheses. No operations, no operations, no operations. They're just final numbers. You don't have to worry about the parentheses portion of PEMDAS. We have no exponents, so we can skip that. So we move on to the multiplication and division. 3 is not being multiplied by anything, but this negative 2 and this negative 1 are. So this is going to become positive 2, plus 2. Because 2 negatives multiplied together make a positive. Okay? Then we can multiply the 3 by negative 1, which is negative 3. So you can write it like that. Or you could have written minus 3. It does not matter. They mean the same thing. Add or subtract from left to right. So the first two together is 5 plus negative 3. And as you guys learned in section 1, really with the associative property, it didn't matter if you would have added these two together first and then add the 3 in. Okay, it just depends on which two you want to group together first. 5 and negative 3 is 2, and that's our final answer. When it gives you values to plug in, your final answer will just be one number. Okay, there's nothing else to it. Make sure you don't leave it as 5 plus negative 3. Actually go through and do that adding or subtracting. All right, so you have some practice. There are 3 problems here. Go ahead, I will walk around. We will help you, but let's try those 3 problems. Okay, so I went through, I put in the variables, okay, and I rewrote that division. I cannot stand that division sign because it always throws people off. Whenever I see a division sign, I always change it to a fraction because division is a fraction. Fractions are division. Okay, so instead of writing it negative 2 divided by 4, I changed it to negative 2 over 4. All right, do we see that? And that was something that I noticed that a lot of people struggled on, was that part right there. Because negative 2 over 4 reduces. What does that reduce to? Negative 1 over 2. So I'm going to instead write this as 4 plus negative 1/2. And what is 4 and negative 1/2 together? What would probably be the easiest way to write that? If you have 4 pizzas and take away half of one, how many do you have left? Anyone? Three and a half? That'd probably be the easiest way to write it. There's a mixed number there. That would be your final answer. If you're not sure how to get it there, instead what you could do is you could write these with a common denominator. That's 4 over 1. So you can write that with a denominator of 2 and make it 8 over 2. Multiply the top and the bottom both by 2, and you get 8 over 2 plus negative 1/2, which is then 7/2 for your final answer. 7/2 and 3.5 are the exact same number. One's just a mixed number, one's an improper fraction. In this case, I really wouldn't care which way you would leave it. Okay. For most situations, I would prefer you to have an improper fraction as your answer. But if you got to this point, 4 plus negative 1/2, it's very easy to get to 3.5 without a calculator or anything. Whereas this would have taken a little bit more work. You see the difference? So either of those answers would be acceptable. All right, number 2. This one was looking pretty good when I was walking around. Many people did their multiplication first. They had 12 and 8 because negative and a negative multiply to a positive, plus 4. What happens in that last one when you subtract a negative number? What happens when you subtract a negative? It what? It turns into addition, so we end up with plus 2. Now remember when I said put all those parentheses in? This is what I was talking about. A lot of times people wouldn't even recognize those 2 negatives because if they didn't put it in parentheses, a lot of times one of them ends up being forgotten about. And we don't want to forget about any parts of an expression. So put them in those parentheses. And then from here, just add them up. I like to group things together, so 12 and 8 is 20. plus 4 and 2 is 6, and 26 for the final. Did anyone get 26 for that one? I thought I saw a couple people have it out there. All right, let's go through that last one too. All right, so this one we wrote everything out. Again, see that division? See how ugly it looks? Let's write it differently. Okay, let's write it as 4 plus 2 times 4 would be on the top, because the multiplication is always on the top of your fraction. It's dividing by -2, so we'll put -2 on the bottom. And then we have minus 2 times -2. And that's going to be a little bit more friendly to us. Okay, so writing those divisions as fractions, just they look more appealing. All right, so then you can go through and you can simplify the multiplication and the division. So 4 plus, this is going to be 8 on top over -2. And the negative times the negative, again, changes that to addition, so plus 4. We still have to do the division there in the middle. So 8 divided by -2, what does that turn into? -4. I'm just going to write it like this because I'm running out of room. Well, 4 minus 4 plus 4 is just 4. So our final answer there is 4. Did anyone get 4 on that one? A couple people? Awesome. Very nice. Very nice. Those were tricky. I don't like those division symbols. I like fractions way better. Okay, go ahead and let's flip the page. On this chart, these are going to be properties for simplifying algebraic expressions. So it says, let A, B, and C represent real numbers. And we have a list of different properties. Most of these properties, they're going to look funny when we write them with variables, but it's things you've already been telling me today. Like if I had A minus B, this definition of subtraction, that is the same thing as having A plus the opposite of B. When you are subtracting, it is the same thing as adding a negative number. The definition of division says that if you had A divided by B, you can write this as A over B. So you can write it as a fraction. You're dividing by B, that's just in the denominator. Okay? And that could also be written as A times 1 over B. Because if you notice, if you had A, this is technically A over 1. And when you multiply those fractions together, A times 1 would be A on the top. 1 times B would be B on the bottom. So you could write them as 2 separate fractions also. The distributive property for subtraction, okay, if you had a number out front and then a subtraction problem inside parentheses, the distributive property would just say that you're going to take that A and you multiply it by both terms inside the parentheses. So this is the same thing as taking A times B minus A times C. Raise your hand if that distributive property looks familiar. You guys remember doing that? I got some nods, I got some hands up. Okay, good. All right, multiplying by 0. If you take 0 and multiply by a variable, or by anything, what do you get when you multiply by 0? 0. Okay. If you have -1 and multiply by anything, it just becomes the opposite. Remember we talked about opposites the other day, so your sign would change. If you multiply by -1, your sign, whatever you originally had, is going to then change. The opposite of a sum says that you're going to negate. Sum is adding of two numbers, so A plus B. Again, this is just like the distributive property where that negative sign has to actually go to both of those terms. So this would be -A plus -B. If you had the opposite of a difference, so opposite of two numbers that you're finding the difference between, what would happen here is you'd also distribute that negative sign. So you would have -A, but you would end up with plus B because you're subtracting a negative. And some people, if they have a negative and a positive, they would like to rewrite that as B minus A, which from those properties we talked about the other day, you're allowed to do that because you can reorder addition and subtraction as long as you keep the negative where it's supposed to be. All right, the opposite of a product. Product is the answer to a multiplication problem. So if you take the opposite, you are only multiplying it by -1, technically. It doesn't matter where you think about that negative as. You could have -A times B, or it could be A times -B. But there's only one negative in there. So when it is multiplying, you don't all of a sudden distribute it like you do when it's adding or subtracting. Okay? It is only applied the one time. The opposite of an opposite. If you have negative of a negative number, what's negative of a negative? Positive. So it just becomes A. Okay. So on your assignment today, you'll have some examples, and then you'll just have to match them with which property it represents. Okay, it'll be matching. Example 2 is to simplify by combining like terms. Okay, so like terms have to have the same variables. So for the first one, 3k minus k, what is the coefficient in front of that k? What is it if we can't see it? 1. So if it helps you to write in that 1, you can do so. 3k minus 1k. If I have 3 cookies and I take away 1 cookie, how many cookies do I have left? 2 cookies, so I have 2 K's here. In part B, you're looking for, there's a couple different types of terms there. We have ones that have z squared on them, so those are like terms. And the ones that have just z, these are like terms. Okay? You can't combine them. It's like combining cookies with cake. It's something different if you mix them up. You don't have cookies and cake anymore. I don't know what you would have. Cakeys? I don't know. So, you don't mix them. You keep them separate. What is 5z squared minus 8z squared? How many z squareds do we have now? -3z squared. And then the -10z and a 1z, -9z. So minus 9z or plus -9z, it does not matter. All right, now this one is a little bit trickier because there's some things you have to do before you can go through and combine like terms. There are parentheses there, so we're going to have to distribute before we can combine like terms. So you're going to have to distribute that -2, and you're going to have to distribute that 7. And when we do that, we're going to get -6xy squared minus 10x squared y plus 7xy squared plus 14y. Sorry, my hole punch got in the way. And now in this one, it's a little bit trickier to see which ones are like terms. So xy squared, we have to find exactly the same thing. This one is not matched. Xy squared, those two match. Sometimes people like to circle the ones that match. That one doesn't have any matches because the only one left would be the y, and those don't match. So -6 and 7 is just 1. So we have 1xy squared. That one didn't change, and neither did the 14y, so we're just rewriting those ones back in. Did I have to write the 1 right here? No, but if it helps you, you can write it in. Okay. There are 2 for you to practice on your own down at the bottom, so go ahead and you can practice those ones. How did A go? Give me a 1 through 5. I got the whole thing down to a 1 is, oh, I'm still sleeping this morning. I got no numbers. Oh, goodness.
Give me a wave if you're awake.
Okay. Okay. Are we seeing what we did wrong? I see some people already erasing, so that is okay. If you want to use colors and circle the like terms in different colors, or use different symbols and circle the like terms, underline other like terms, put arrows on the other like terms, you can do that. Sometimes it's easier to visualize that way. So when you have a subtraction sign, though, you have to think about that as plus -4x. So that'll be a negative there. So 2 minus 4 minus 1. Where did I get x squared from? I don't know either. How many x squared should I have there? -3. There we go. That looks better. Maybe that's why I had no numbers. Okay, so 2 minus 4 is -2. Minus another 1 is -3. I must have skipped that middle term. All right. Then 5x and 1x makes 6x. Are we better? Does that look better? Okay, so raise your hand if you got that. Okay, cool. Whew. All right, one thing I was going to tell you here is this was to simplify it. Now, if I was asking for you to evaluate at x's, maybe I said evaluate this at x is 3, and that's all I would need. Would you rather plug it into the original, or would you rather plug it into what you simplified it as? Which one would you want to plug it into? This first messy one, or this one that's only 2 terms? Probably the one with 2 terms. So one of the things you may want to do is if you're asked to evaluate, it might be simpler to simplify it first, then plug in that value. You're going to get the same thing either way, because when you simplified this, you didn't change the value of anything. You just made it look a little bit nicer. That's it. Okay. How did this one over here go? Looks good? All right. Well, if those look good, that's all we have for you.